So hello everyone, this is Akshay Verma and today I am going to discuss a latest lead code contest problem. The name of the problem is apply operation to make two strings equal. So in this problem we have given two strings and we have to convert string 1 to string 2 by applying some number of operations. So there are two operations that we can apply. The first operation is we can randomly choose two indices I and j and we can flip the values at both the indices. Means what is the meaning of flipping it? We can convert 0 to 1 and 1 to 0 and these strings are binary strings, so it contains only 0 and 1. So in the first operation we can choose two indices and we flip the values of both the indices. And in the second operation we can choose two consecutive elements, mean the element at index I and the element at index I plus 1, and we can flip the values of both the indices. Means we can convert 0 to 1 and 1 to 0. So the cost of this operation is 1. So now we have to return the minimum cost we need to make string 1 to string 2, and if it is not possible for us, then we have to return -1. So now the first observation is, for each time we are changing for two positions, means the total number of conversions is even because we are changing for two positions, or we are converting two positions each number of time. So the total number of conversions is even. Means I am not talking about the position, I am talking about the conversion. So the total number of conversions is even, and if we need odd number of conversions, then of course it is not possible for us to convert these things. What I am saying is, let's take an example. So yeah, so let us suppose we have something like 1 0 1 and here we have something 0 1 0. So the value of x is anything, let's take 10, anything. So now if we need to change this string to this string, so here if we change these two positions, so it becomes 0, it becomes 1, and it is, let's take, so yeah, so it becomes 0 1 1, and we have to change this to 0 1 0, right? So now if we again change, now we want to change this element, right? Because this thing and this thing is equal, so now we want to change for this element. So for changing this element we need at least one element from this side. Why? Because we will be able to apply operation on the pairs, means on two elements. So for this element, for pairing this element, we need one extra element. So if we choose this element or this element, then the value of that element again changes. Let us suppose I choose this element, right? So it becomes 0. Now the value of this element again changes, it becomes 0 and it becomes 0. So now it becomes 0 0 0. Now again for this element it is not matching. So it is not possible for us if we need odd number of changes, right? Because for each time we are converting even number of times. So this is the first observation, means if the number of positions where this string is not matching is, if the total number of positions is odd, then we can simply return -1, or we can do something. So now what we can do is, we just apply some number of operations, and of course if the number of positions where the strings are not matching is even, then there exists at least one path by which we can convert string 1 to string 2, right? So we have to return the path by which the cost is minimum, right? So yeah, so now what we can do is, means the first approach that comes in anyone's mind is, means why let's try greedy, right? So yeah, so let us suppose we have two strings. Let's consider two strings. Let us suppose we have 1 1 0 1 0 1, whatever, right? And let us suppose here we have 0 0 1, then again 1, then let us suppose 1 and whatever, right? And let us suppose the x is anything, x is 3 4 5, whatever. So now, so the greedy thing that comes in anyone's mind is, if we need to change the two consecutive elements, right, then we can use the first operation. Why first operation? Because the cost of first operation is only 1 and it is minimum possible, because the value of x is also in between 1 to 500, right? The minimum value of x is 1 and the maximum it goes till 500. So the minimum value of x is also 1 and the cost of first operation is also 1, so it is minimum. So if we got two consecutive element that we need to change, then we can apply the first operation. And if we got two elements that are not consecutive, then we can apply the second operation. So this is the greedy approach, but it will fail, right? Means there are some test cases where it will fail. So let's consider that test case also. Let us suppose we have something 1 0 0 1, and let's suppose we have 0 0 0 0. and let us suppose the cost is 10 or anything, whatever. Now we need to convert this string to this string. So since we need to convert these two elements and these two elements are not consecutive, so we can apply the second operation and the minimum value that we got is 10. Now there is one more approach by which we can change the first string to second string. We have 1 0 0 1. So first we will change these two by applying the first operation, so it becomes 0 1 0 1. Now after that again we change these two, so it becomes 0 0, it becomes 1 and it becomes 1. Now if we again change these two, then it becomes 0 0 0 0. So now the cost is only 3, and here we have got the we are getting the cost 10. So of course this one is minimum. So in this case the greedy technique will not work. So of course we have to explore all the path, and for exploring all the path we need dynamic programming, use TP. So of course we can use TP, means we can explore all the path, and we only consider that part which gives the optimum result, means which gives the minimum result. So now the question is how we can apply dynamic programming, right? So let us suppose we have any string like this 1 0 1 1 0 1 1 or whatever. So for each operation, means what I'm doing is, means I'm starting from this side, means if I'm at this index, that means we have worked on these indexes, means these are equal to the second values of the second string. So if at any index we have two options, means either see for any index there are two things, means let us suppose here also we have 1 in second string, if here also we have 1. So if here we have 1, then we don't need to do anything, because we are moving from left to right. That means the things that are here and the things that are here are definitely equal, because we are currently we are at this index. That means the things here and here are equal. So for this index, if the value is same, then we don't need to do anything. But if the value is different, let us suppose here we have 0, then we have to do something. Means either we can apply the first operation or we can apply the second operation. Means we can apply both the operations, and after applying both the operations, from where we are getting the minimum result, we just return that result. Means we will try, we will have to try both the operations. So this is what DP is. Means we have to explore all the path. So we can apply both the operations. Means first we can change. We apply the first operation. Means we can flip these two values, and the cost of this operation is 1. Now for second operations we need two elements, right? So there is one more case. Means let us suppose we are applying second operation. So let us suppose this is the string 1 0 1 1 0 1 1. So if I'm applying the first operation, then nothing, we just need to consecutive element and we change them. But if we are applying the second operation, then we need to take care of, means whether we are applying the second operation first time. Means what I'm saying is, in second operation we can choose two indices, right? So if we consider this index and paid the cost x, then if we apply the second operation second time, means let us suppose I apply second operation on this index also, then we don't need to pay anything, because we already paid x amount, and by paying x amount we will be able to change two different indices, and here we only change one index. So this index we can change, we can also change, right? Because we already paid x amount. But if we are applying the second operation first time, then we have to pay x amount, otherwise we don't need to pay. Means we can apply this operation in pair, right? So if we are making the pair first time, then we need to pay x amount, otherwise we don't need to pay anything. So we have to also keep track or we have also keep count, means whether it is the first element or we can already pay the x amount. If we already paid it, then we don't need to do anything, otherwise we need to pay, right? So let's see the code and try to understand more. So this is the code for the sale. Means what I'm doing is, first I'm finding the count of the positions, means total number of positions where we need to change. If this is odd, then we can simply return -1, or we can do something. Means what we are doing is, means if this is not odd, right, then what I'm doing is, if the values of both the positions are not equal, if the values are not equal, then either we are applying the first operation, means in first operation we are changing two consecutive, means at I and I+1 we are flipping both the values and then finding the result for rest of the string, or okay, So if the values are not equal, then we are applying the first operation, and means we are changing the values at I and I plus 1. So and we are finding the result for rest of the string, and after that we again flip the values. This is something like backtracking. We are always flipping the values, and then we are applying the second operation. Means if count, so count indicates whether this is the first time we are applying the second operation, or we can got the value of first thing in the pair, right? So if count is equals to 1, that means okay. So if count is equal to 1, that means that means we already paid the x value, so we don't need to pay anything. So here we are not paying anything, and we are just moving ahead, means I plus 1. And if the value of count is 0, that means we need to pay anything. Then first we make count is equal to 1, because for next time we don't need to pay anything, and we are paying x amount, means x plus the rest of the string. We are finding the result for rest of the string, and we are consider the minimum of both these values, means answer 1 and answer 2. The result we got from the first operation, and the result we got from the second operation. We are taking the minimum one. And if the values are equal, means if s1 of I is equal to s2 of I, means if the values are equal, then we don't need to do anything. We just move ahead, means we are just moving ahead by doing I plus 1. So this is the simple recursion, and I am doing memoization because the values are very less, means I goes till 500, so I'm just considering 505 for the safer side. And the count is going till 2, means either the count is 0 or the count is 1, because the pair contains only 2 elements. So the count is only 2, means whether it is the starting of the pair or it is the ending of the pair. So it is only contain 0 and 1. So by doing this, we are just simply memoizing the solution. You can also convert it to tabulation form. Yeah. So this is it for the question. Thank you.